Hey, everybody. So, we are going to talk about going between mass and moles as units in this video. Okay. And so, we've talked about the mole before, and we talked about how it just represents a number, right? And it's just a very, very large number. So, remember, 1 mole of H2O is going to be equal to 6.02 times 10 to the 23rd molecules of H2O, right? And so, that mole always equals that 6.02 times 10 to the 23rd number. And so that is a very, very large number. And so the mole is there for us to easily kind of conceptualize like how much of a substance we have, right? Um, and the mole, the brilliant thing about it is that we can use it to kind of relate substances to one another when we, have a reaction or something, right? And so when we have uh, you know, water and lead involved in the same reaction, if we have 1 mole of water, saying 1 mole of lead, we can see that we have, we're talking about the same thing there, right? We're talking ultimately about the number of atoms or molecules that are involved, but through the lens of the mole here, right? And so uh, what we can do here is we can kind of start to do some qualitative chemistry, right? Meaning, or I'm sorry, some quantitative chemistry, meaning quantities or numbers. And so the question that we want to answer and ask ourselves is, what happens when I want to know how many moles of a substance I need, or how many moles of a substance I make for or in a reaction, right? And so when you're in a chemistry lab, you don't go into a lab and measure out 2 moles of water, right? There's no scale that's going to measure out the moles in that way. But we do have ways where we can measure out the grams or the liters of a gas or a water or a liquid, I mean. And we can figure out how many moles we have that way. And so the way we're going to do this is we're going to use molar mass to relate moles and mass, right? Because the molar mass uses both of those units. It's grams per mole. Is what molar mass is. And so if we want to find, the number of moles that we have in a certain mass of a substance, we can use the molar mass to help us do that, right? So let's look at an example here before we try a couple on our own, okay? So the molar mass is going to be key in solving these problems, right? And so the kind of problem that I'm talking about here is one like this. While doing some experiments in a lab, a scientist has 32.6 grams of magnesium chloride. Okay, we want to know how many moles of magnesium chloride does the scientist have. Okay, and so that is where the molar mass and the mole kind of play into each other. Is we want to be able to predict how much of some substance is made in this reaction, but in order to do that, we've got to know how many moles we currently have being reacted. Okay, and so we're going to do this with the molar mass. And so we're going to always start with what we are given, which in this case is 32.6 grams of MgCl2 or magnesium chloride, right? And you can see I'm given that right here. This is what we're starting with. It's our starting point. What we want to end with is how many moles, right? So that's what we're looking for. That's what we're trying to find in this problem. So we've got to go from grams of magnesium chloride to moles of magnesium chloride at the end of here, and we need to know how we get from one to the other. And it turns out that molar mass, grams per 1 mole here, right? Remember we have this little guy right here, our 1 mole, and then we have our mass up here in grams, okay? That is how we're going to go between grams and moles here. So what we do, let me scoot down here, is let me get these red X's out of here. I apologize for that. We're going to use the molar mass of magnesium chloride, right? And if you don't know how to calculate the molar mass, you can go look at that video or come to class and get some help on that. But we're taking the moles of magnesium chloride. So we've got 1 mole of magnesium and 2 moles of chlorine in here. We would find the masses on the periodic table. Magnesium is around 24, chlorine is around 35.7, and so that gives us around 70 from the chlorine and around 24, 25 from the magnesium. And so when we add that up, we get 95.21 grams of magnesium in 1 mole of magnesium, right? And so we are going from grams of magnesium chloride to moles of magnesium chloride. And we need to set up this ratio so that way our grams unit cancels out, okay? So typically, our molar mass would be written grams per mole, right? So we would have 95.21 grams for every 1 mole. But we can flip that around where we have 1 mole in that many grams whenever we need to cancel our units out, right? And so that's what we're doing here. Is we have 32.6 grams of magnesium chloride times 1 mole of magnesium chloride over 95.21 grams of magnesium chloride. Our grams are going to cancel out, okay? And then we're going to be left with our answer here, which I apologize, should be, I think it's hidden here. I'm sorry. Let me find it. No, it's just not there. Okay. So we would divide here. I'm sorry. We would do 32.6 times 1 divided by 95.21. And so we're going to end up with an answer of 0.342 moles of magnesium chloride, right? And if we think about that answer logically, that makes sense. Okay, we have 32.6 grams of magnesium chloride that we're working with, and we know that in 1 mole of that, we have 95.21 grams, right? And so if we're thinking about the size of our sample here, that is about, 1/3 of the molar mass of our substance, and 0.342 is about 1/3. So we get an answer that makes sense there, okay? So what we're doing is we're just taking the molar mass and we're using it to find the number of moles, or we can do this in reverse. We can find the number of grams as well. Okay, so let's look at another example here. So let me go back to my pointer. Okay, so now we can come here. So let's try this. If a scientist knows they have 2.87 moles of water, how many grams of water do they have, right? So again, here we're starting with a different point. Instead of starting with grams, we're starting with moles. But we're still going to be using grams per mole or molar mass in order to find our answer here. And so what we do here is we will be taking the 2.87 moles of H2O, which is what we're starting with, right? And we're trying to find grams of whoops, I don't know what happened there, H2O. And our way to relate grams and moles of H2O is the molar mass. And so the molar mass is given to you here. The molar mass of water is 18, right? We have 16 grams from oxygen and then 1 gram each from hydrogen. There's 2 of them, so that's 16 plus 2 is 18. So when we do our problem here, if we want to find how many grams of water are in 2.87 moles of water, we would just simply multiply 2.87 times 18 and then divide by 1, and that's going to give us 51.66 grams of H2O. And again, that makes sense, right? Because we have, if we look here, we've got 2.87 moles of water, right? That's almost 3 moles of water. And so if we have, 18 grams in 1 mole, then we should expect, close to 54 grams in 3 moles almost, right? So that's where we get this 51.66 answer here. So we multiply on the top, we divide by everything on the bottom, and then those units, moles of H2O and moles of H2O, cancel out. So we don't have an assignment over this, but I do want you to try 2 of these problems on your own here, okay? And so the first one I want you to look at here is the first one here. If I have 0.79 moles of carbon dioxide, how many grams of carbon dioxide do I have? Okay, and I'm giving you the molar mass here. Carbon dioxide has a molar mass of 44.01 grams per mole. So you're going to have a question pop up that you have to answer. Tell me what the answer is. How many grams of CO2 do I have in 0.79 moles of carbon dioxide? Go ahead and answer that, and then I will go through how to solve that. Okay, hopefully you had a chance to answer that, and now we're going to go ahead and solve this, okay? So when I set up these problems, I always start with what I'm given. So I have 0.79 moles of CO2, okay? Now, I'm going to be multiplying this by the molar mass. I want to get to grams of CO2. So I put my grams of CO2 on the top. That means I'm going to put my moles of CO2 on the bottom, right? Because I want those units to cancel out. And when I look at grams of CO2 per moles of CO2, that is molar mass. And so that is going to be 44.01 grams of CO2 for every 1 mole of CO2. Okay. Now, when I multiply across, I multiply 0.79 times 44.01. My units, moles of CO2, are across from each other. And my answer here is going to be, let me get that back to red for us, 0.79 times 44.01. That should be around 34.7 grams of CO2. Okay, sorry, that's very ugly there. CO2. So, hopefully, that is the answer that you got there. All right. Now, let's go ahead and try one more. We are going to look at this problem down here. I have a sample containing 876 grams of propane, which is C3H8. How many moles of propane is that? And again, I give you the molar mass of propane here, which is 44.01 grams per mole. All right, so try that. Tell me how many moles of propane I have in 876 grams. Okay, hopefully you were able to take a second and solve that. So again, we start with whatever we're starting with here. I have 876 grams of C3H8. Okay. We need to go to moles of propane. So I have moles of C3H8 here. All right. I'm going to put that over grams of C3H8. So you can see I've set up my ratio here. So when I multiply, I'm multiplying by 1 mole over 44.01 grams times of C3H8, okay? And I've done this again, so that way my units of grams of C3H8 will cancel out, and I'm simply left with a unit of moles of C3H8. So when I do 876 times 1 divided by 44.01, that gives me 19.9 moles of C3H8. Okay? So, that is all we have for this video today. Next week, we will examine going from moles of one substance to moles of another substance, and then, briefly on grams and moles again. We'll have a quiz on that, and then we will move into our mastery for this unit and start to move into something else from there. All right, so thank you for watching. No assignment over this currently, and I hope you have a great day.